Okay, so this is the last lecture I'm proposing to give for this course. Okay, so there is, in the course structure on mold, it does actually say one more revision lecture, but I'm hoping we can do a review of a past exam paper in this lecture, and then the tutorial sessions will keep going right up to week 12. Okay, so if you need extra input from myself or from, we have some helpers on the tutorial sessions, then please come along to them. Okay, so I'm going to do a quick summary of the course, what we've covered, and then we're going to do a review of a past paper. We're going to go through last year's exam paper. Well, we'll start going through it, we'll see how far we get. So, summary of what we did. We did, started with what you might call mechanical vibrations. Okay, so this is the sort of classic theory of vibrations of a single degree of freedom system, and we included things like harmonic motion, and sine waves, didn't we? Basically, we said that everything was a sine wave. We did free vibration, where the system is just released from an initial condition and then allowed to oscillate, and so of course it decays away because there's no energy being added into it. And so we did the log decrement, didn't we, as well, which was a method for estimating from that decay what the critical, what the relevant damping parameters were. So we did, after that we did forced vibration. So this is when we're shaking it with some external force, and we can either shake it directly, or remember we also had the case of a rotating out of balance mass, didn't we? And we did two types of sort of analysis. We ended up with the dynamic magnification factor. It is also called dynamic amplification factor. Either amplification or magnification is fine. And we also did transmissibility, didn't we? So that's transmissibility is when you're shaking the support that the oscillator is attached to. Okay, so if we're applying the force to the oscillator itself, we get the dynamic magnification. If we're applying the shaking by moving the support, then we get transmissibility. So we then did some system models. Particularly we looked at things like equivalent stiffness. So we used our energy functions to draw an equivalence between a certain system and then a simplified version of the system. We talked about damping, and how, which means how energy is lost from the system, and we had different cases. We had viscous damping, we had friction damping, and we had things like hysteretic damping as well. So that was all in the sort of first half of the course. Second half of the course was about rigid body dynamics. And there we started with kinematics. And we talked about translating and rotating frames. and we did everything in terms of vector algebra. We did kinetics, and particularly looked at angular momentum. We did balancing of rotors. And last lecture we talked about the tabular method for doing that. And then lastly we did gyroscopes. And of course we talked about things like precession and the gyroscopic moment, didn't we? So, that's a summary of what we did in the course, just briefly going through the, highlighting the main topics.